This is SpaceTime Series 21, Episode 35. Coming up on SpaceTime, the massive cloud on a collision course with the Milky Way, and plans for a Martian sample return mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A massive cloud, some 2 million times the mass of the Sun, moving at well over 1 million kilometres per hour, is on a direct collision course with our Milky Way Galaxy. In 1963, an astronomy student named Gail Smith, working at an observatory in the Netherlands, discovered something odd: a massive cloud of gas orbiting the Milky Way Galaxy. For the next 40 years, the Smith cloud remained somewhat of a curiosity, one of a growing number of so-called high-velocity clouds circling the Milky Way. Interesting, but not sensational. Then something changed. In the mid-2000s, radio astronomer Jay Lockman and colleagues took a closer look at Smith's cloud using the Green Bank Radio Telescope in West Virginia. They were able to calculate its orbit, and Smith's cloud, it turns out, is on a collision course with the Milky Way. 30 million years from now, give or take a few million years, it'll crash into the Perseus arm of our galaxy. The impact will compress clouds of gas in that spiral arm, causing what should be a brilliant burst of star formation. Now, there's no real danger to the Milky Way. After all, the Smith cloud is minuscule compared to the gigantic spiral of stars that make up the backbone of our galaxy. But the coming collision has sharply increased interest in Smith's cloud. Andrew Fox from the Space Telescope Science Institute in Baltimore, Maryland, says astronomers don't fully understand the Smith cloud's origins. There are two leading theories. One is that it was blown out of the Milky Way, perhaps by a cluster of supernova explosions. The other is that the Smith cloud is an intergalactic object that's been captured by the immense gravitational pull of the Milky Way. To investigate these theories, Fox and colleagues peered into the cloud using the Hubble Space Telescope's Cosmic Origin Spectrograph. One of the elements they discovered was sulfur, absorbing ultraviolet light from the bright cores of 3 galaxies far beyond the cloud. By analysing the amount of light Smith's cloud absorbs, the authors were able to measure the abundance of sulfur in the cloud. And they found the level to be very similar to the abundance of sulfur within the Milky Way's outer disk. In other words, the Smith cloud was once part of the Milky Way. Fox thinks the cloud must have been ejected from within the Milky Way and is now falling back into it. But it's not as simple as that. The cloud's fragmenting and evaporating as it ploughs through the halo of diffuse gas surrounding our galaxy. Basically, it's falling apart. So this means that not all of the material in Smith's cloud will survive to form new stars. But if it does survive, or at least if some major parts do, it should produce an impressive burst of star formation. While Fox's work has now cleared up some of the mystery surrounding the Smith cloud, many questions remain. For example, what sort of calamitous event could have catapulted it from the Milky Way's disk in the first place? And how did it remain intact? Still only 30 million years to impact, and the clocks are ticking. You're listening to SpaceTime. I'm Stuart Gary. NASA and the European Space Agency have agreed to develop a joint Martian sample return mission to bring rocks and soil back from the red planet to Earth. Spacecraft now in Mars orbit and on the red planet's surface are continuing to make important discoveries about the evolution of the atmosphere and geology of Mars, in the process transforming science's understanding of the red planet and unveiling new clues about the formation of our solar system. The research already shows how what was once a warm, wet world capable of harbouring life was transformed into an inhospitable freeze-dried desert more than 3 billion years ago. As the red planet cooled down, its molten liquid metallic core began to solidify, shutting down the geodynamo-generated magnetic field which shielded Mars and its atmosphere from the radiation and erosive effects of the solar wind and cosmic rays. As the Martian atmosphere was either degassed or blasted into space, it became too thin to support the pooling of liquid water on the planet's surface, which was also being irradiated by the constant bombardment of charged particles. What's left now are windswept sand dunes and long dried-up riverbeds, the cracked branching remains of withered river deltas, dry shriveled lake beds, and the vast, now dried, empty abyssal expanse of what was once a great northern hemisphere-wide ocean. Researchers believe the logical next step would be a sample return mission, bringing rocks, soil, dust and atmospheric samples back from Mars for detailed analysis in sophisticated laboratories where results can be verified independently and samples reanalyzed as laboratory techniques continue to improve. But bringing bits of Mars to Earth will be no simple undertaking. It'll require at least 3 missions from Earth and one never-before-achieved rocket launch from Mars. A first mission, NASA's Mars 2020 rover, is all set to collect surface samples in pen-sized canisters as it explores the red planet. Up to 31 canisters will be filled and readied for later pickup. Around the same time, ESA's ExoMars rover, which is also set to land on Mars in 2021, will be drilling up to 2 meters below the surface to search for evidence of life. A second mission, equipped with a small fetch rover, would land nearby to retrieve all the samples. This rover would then bring these samples back to its lander and place them in a special Mars Ascent vehicle, a small rocket to launch a football-sized container of samples into Mars orbit. Then a third launch from Earth would provide a spacecraft sent to orbit Mars and rendezvous with the sample containers. Once the samples were safely collected and loaded onto an Earth entry vehicle, the spacecraft would return to Earth and release the Earth descent vehicle to land in the United States, where the samples would be retrieved and placed into quarantine for eventual detailed analysis by scientists. All previous Mars missions have revealed ancient riverbeds and the right chemistry that could have supported life on the red planet. A sample return mission would provide a critical leap forward in understanding Mars's potential to harbour life. You're listening to Space Time. I'm Stuart Gary. Okay, let's take a moment out of the show so I can tell you about our sponsor, The Great Courses Plus. You listen to Space Time because, like me, you're curious and you've got this thirst for knowledge. It's not just you wanting to know more, you need to know more. It's part of your makeup. It's what makes you who you are. But sometimes life gets just a bit too hectic with careers and families and everything else. You just don't have the time to invest in a university course. And that's why I recommend signing up for The Great Courses Plus. With this fantastic streaming service, you get to learn about pretty well anything that interests you from the world's very best professors and experts. Be it astronomy, history, the arts, how to take photos, play chess, or learn a new language. The Great Courses Plus have what you're looking for. You'll get unlimited access to thousands of lectures to watch from your TV, computer, or mobile device. Or you can listen along through the Great Courses Plus app. Take it with you on your commute to work and switch from audio to video whenever you want. Now, as I mentioned last week, the course I'm taking now, which is pretty cool, I'm sure you'll love it as well, is a visual guide to the universe. It's created in partnership with the Smithsonian. And we're not talking about dusty old museum pieces here. We're talking about the latest up-to-date information, exploring how astronomers use data from orbiting telescopes like Hubble, Spitzer and Chandra to develop a working knowledge of planets, stars, galaxies and the universe. Did you know that at the moment there are more than 70 scientific spacecraft and space-based observatories out there? It's a lot of data they're feeding back to Earth. And with the Great Courses Plus, you can be a part of that, soaking up that knowledge. And because you're a listener of SpaceTime, we have a special offer for you. To get started with the Great Courses Plus today, we've arranged a special limited time offer for our listeners. A full month to enjoy the Great Courses Plus, and it's for free. Take as many of their courses as you like, all for free for 30 days. That's how good we think this is. And we know once you'll start, you'll want to hang around because the courses really are that good. But the only way you can get this free month offer is to sign up through our special URL. Just go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course, we'll include the link in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to the show. Europe's Sentinel-3B Earth Sciences satellite has successfully launched into orbit, providing scientists with another set of eyes to study the Earth's rapidly changing environment. Sentinel-3B will join its identical twin sister Sentinel-3A, systematically monitoring Earth's oceans, land, ice and atmosphere, and carefully looking for changes in the planet as the worsening effects of climate change take hold. The launch was the 7th in 4 years for the European Union's Copernicus Environmental Satellite Monitoring Network. Copernicus is the world's largest single Earth observation program. The 1,150-kilogram Sentinel-3B spacecraft was carried into orbit aboard a Russian Rokot rocket launched from the Plesetsk Cosmodrome some 300 kilometers north of Moscow, near the Arctic Circle.
And there we go. We are off. Rokot is hauling itself against the gravity of our planet. The first stage is pushing us away from Earth. We need a lot of firepower to do that. Nick, what's our trajectory?
So at the moment we're heading north-northwest, so we're heading up over the Arctic Ocean, and we're heading in this directory because we want a polar orbit when we finally separate, so that Sentinel-3 will be roughly 98 degrees in inclination, which is the angle from the equator to the orbit.
Philippe, what's happening to your satellite right now?
I can tell you it's always a little bit of an emotional moment. I think that launching a satellite in orbit is similar to launching a ship at sea. You know, you have worked for it, you've waited for this moment, and here it comes. You know, our satellite, once it's in orbit, is in a very smooth environment for what concerns at least the mechanical environment, because it's just floating in the air once up there. But now, for this launcher, you can see with this big boost and all the vibration that goes to it, it's a very bumpy ride, really.
It is in the first phase of the flight, isn't it? But right now we have separation of the first stage. We're now burning the second stage, Nick.
Yep, this burns for about 3 minutes, and it takes us right over the North Pole, and at the moment we need to accelerate. So we've gained a little bit of altitude, but we need to go fast enough so that when we stop burning, we can actually stay in orbit.
So we've gone above what's often known as the Kármán line, which is effectively the border with space. It's about 100 kilometers above sea level, 62 miles. What does that actually mean, Nick?
So at this point, the air is so thin that the force required to fly in an aeronautical regime, so like an aeroplane does, is more than actually a rocket needs to fly in an astronautics domain. So this is really the rocket science that needs to keep us there, and it's the boundary between aeronautic ending and astronautic beginning.
Identified by a Hungarian-American aerospace engineer called Theodor von Kármán, and he was born in 1881.
Rokot's upper stage delivered Sentinel-3B to its planned orbit, and just 92 minutes after liftoff, the probe sent its first signals to ground tracking stations in Sweden. Data links were then quickly established by teams at the European Space Agency's Missions Operations Centre in Darmstadt, Germany, allowing them to take over control of the satellite. During the 3-day launch and early operations phase, mission managers checked that the satellite systems were all working correctly, and they began the process of calibrating scientific instruments to commission the satellite. Sentinel-3B is expected to begin its routine operations in about 5 months' time. Like its twin sister, the satellite was designed and built by a consortium of around 100 companies under the leadership of Thales Space in France. The two Sentinel-3 probes carry sensors designed to measure the temperature, colour and height of the sea surface, as well as the thickness and extent of sea ice cover. These measurements can then be used to monitor changes in Earth's climate and marine pollution. When flying over land, the Sentinel-3 probes monitor wildfires. They map changes in the way land's being used, check vegetation health, and measure the heights of rivers and lakes. The European Space Agency is currently developing 7 missions under the Sentinel program. The Sentinel constellation will comprise mostly twin satellite pairs, covering specific environmental observations. The 2 Sentinel-1 satellites provide all-weather day and night radar imaging of the planet's surface. Sentinel-1A was launched in April 2014 aboard a Russian Soyuz rocket from the European Space Agency's Kourou Space Centre in French Guiana. Its twin Sentinel-1B was launched almost exactly 2 years later from the same spaceport. The Sentinel-2 twins provide high-resolution optical imaging of land surfaces, including imagery of vegetation, soil and water cover, inland waterways and coastal areas, as well as natural disaster coverage for emergency services. Sentinel-2A was launched in June 2015, followed by 2B in March 2017, both aboard European Space Agency Vega rockets from Kourou. The first of the 2 Sentinel-3 satellites was launched aboard its Russian Rokot rocket from Plesetsk back in January 2016. It's now of course been joined by its twin Sentinel-3B. Also now in orbit is the Sentinel-5 Precursor mission. It was developed as a stopgap measure, becoming the first Copernicus program spacecraft dedicated to measuring air pollution from orbit, pending the development of the Sentinel-5 mission. The Precursor satellite was also launched on a Russian Rokot from Plesetsk in October 2017. Still to fly are the Sentinel 4 and 5 missions, both of which will be scientific payload packages aboard geostationary Meteosat meteorological satellites. Also still in development are Sentinel 6 and 6A, which will undertake high-precision altimetry observations, Sentinel 7, which will monitor carbon emissions, Sentinel 8, which will monitor the Earth's thermal infrared radiation output, Sentinel 9 will be an ice and snow altimetry infrared mission, and Sentinel 10 will be a hyperspectral mission. You're listening to Space Time. I'm Stuart Gary. And time now to turn our eyes to the skies and check out the celestial sphere for the month of May on SkyWatch. Of course, May is the 5th month of the year in both the Julian and Gregorian calendars. The month was named for the Greek goddess Maya, who was identified with the Roman-era goddess of fertility Bonadea, whose festival was held in May. More importantly, for many of our listeners, May typically marks the start of summer vacation season in the United States and Canada. Let's start our tour of the night skies by looking east, where you'll find the constellation Scorpius the Scorpion. In Greek mythology, Scorpius was sent by the earth goddess Gaia to slay Orion the Hunter after he boasted that he could kill all the animals on Earth. Scorpius succeeded in his mission, stinging Orion in the shoulder. But Orion's life was spared by Ophiuchus the Healer, and was placed in the heavens along with Scorpius, who would continue to pursue him for eternity. So Orion the Hunter has become the hunted forever, with Scorpius rising in the east this time of year to triumphantly chase and defeat Orion, who sets in the west. Meanwhile, Ophiuchus the Healer rises in the east following behind Scorpius to crush him back into the earth as the Scorpion sets in the west. And so this ancient story plays out year after year. Interestingly, parts of the story predate Greek mythology, with Orion known in ancient Egypt as Osiris, the Egyptian god of the underworld and regeneration. Now, looking into the constellation Scorpius, you'll notice the bright golden red star Antares, which in Greek mythology represents the beating heart of the Scorpion. Antares means the equal or rival of Mars, because the two do look very similar when seen from Earth. But while Mars is a small neighbouring terrestrial planet, just a third the size of Earth, Antares is a massive red supergiant, some 12.5 times the mass and an amazing 400 times the diameter of the Sun. Although Antares is located some 550 light-years away, it looks so bright because it's around 57,500 times as luminous as the Sun. By the way, a light-year is about 9.5 trillion kilometres, the distance a photon can cover in an Earth year travelling at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit of the universe. Antares' ultimate fate is destined to explode as a Type 2 or core collapse supernova any time now. But of course, in astronomical terms, any time means any time within the next few 100,000 years. When it does go bang, it'll appear as bright as the full moon for several months from here on Earth. Antares has a companion star, a spectral Type B main sequence blue-white star Antares B, which can be seen using a decent backyard telescope. The two stars orbit each other at an average distance of about 224 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. A spectral analysis of Antares B shows that it's pulling a lot of material off its bloated red supergiant companion. Located near Antares from our point of view, and visible through a good set of binoculars, is the M4 globular cluster. Globular clusters are tight balls densely packed with thousands to millions of stars that were all originally formed at the same time from the collapse of the same molecular gas and dust cloud. The M4 globular cluster is located some 7,000 light-years away, making it one of the nearest globular clusters to Earth. Meanwhile, located near the tail of the Scorpion are two open star clusters known as M6 and M7. Open star clusters are loosely bound groups of a few thousand stars, which were all originally formed in the same molecular gas and dust cloud, but are not as tightly gravitationally bound as globular clusters. Therefore, open clusters generally only survive for a few 100 million years, with the most massive ones maybe surviving for a few billion. In contrast, the more massive globular clusters exert such a strong gravitational attraction on their members that many have survived for most of the age of the universe. M6, which is also known as the butterfly cluster, is some 12 light-years across and located about 1,600 light-years away. M7, or the Ptolemy cluster, is named in honour of the ancient Greek astronomer. It's even closer, just 980 light-years away, and is far more dispersed than M6, covering an area about 25 light-years across. By the way, the M in terms like M4, M6 or M7 is an abbreviation of the name Messier, in honour of the 18th century French astronomer Charles Messier, who developed an astronomical catalogue of fuzzy nebulous objects in the sky. See, Messier was a comet hunter, so he compiled a list of 103 fuzzy objects which weren't comets, and so, from his perspective, could be ignored. Later, other astronomers added additional celestial objects to the list, bringing the present-day catalogue up to around 110. Now, last month, you may recall, we took a close look at one of the best-known constellations in the sky, the Southern Cross, or Crooks. If you're in a nice dark location, look south towards the Southern Cross, and you'll notice an extra dark patch between the brightest and second brightest stars in the cross. This is the coal sack, a massive dark nebula of gas and dust, blocking out the light from all the background stars. For Australia's Aboriginal people, the coal sack was the head of the Emu constellation. If you follow the dark dust lanes to the east and use your imagination a bit, you'll be able to make out the emu's body and legs. Also visible this month is the Eta-Aquarids meteor shower, which is generated as the Earth passes through the dust and debris trail left behind by Halley's Comet. Comet P1 Halley is a well-known short-period comet which visits the inner solar system roughly every 75 to 76 years. The 15-kilometre wide mountain of rock and ice will make its next up-close appearance in 2061. It's named in honour of the British astronomer Edmund Halley, who in 1705, after examining ancient Chinese, Babylonian and medieval European records, successfully predicted the comet's return in 1758. Sadly, however, Halley died in 1742 before his prediction could be confirmed. The comet's highly elliptical and elongated orbit around the Sun takes it from between the orbits of Mercury and Venus out to almost as far as the orbit of Pluto. Also, Halley's orbit's retrograde, meaning it orbits the Sun in the opposite direction to the planets, or clockwise from above the Sun's north pole. This retrograde orbit results in Comet Halley having one of the highest velocities relative to Earth of any object in the solar system, some 70.56 kilometres per second, or if you prefer, 254,016 kilometres per hour. As well as the Eta-Aquarids meteor shower every May, Halley's Comet also produces the Orionids meteor shower in late October. Astronomers think Comet Halley was originally a long-period comet, taking thousands of years to travel to the inner solar system from the Oort cloud. But it was ultimately gravitationally perturbed into its current orbit thanks to close encounters with the giant outer planets. The Eta-Aquarids meteor shower runs from the 19th of April through to May 28th. Peaking around May the 5th with around 55 meteors an hour, making it one of the Southern Hemisphere's best celestial showers. However, back in 1975 they were running at 95 meteors an hour, and in 1980 it was up to 110. Even better, the bright yellow meteors often appear as streaks known as trains. They'll radiate out from the direction of the constellation Aquarius and the star Eta-Aquarii, hence the shower's name, the Eta-Aquarids. Just look towards the east after midnight and before dawn for the best view. Jonathan Nally, editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the May night skies on SkyWatch.
G'day, Stuart. Yeah, well, daylight saving is over for another year, and the nights are getting longer as we head into winter, at least for us down here in the Southern Hemisphere. This is actually a really good time for stargazing if you live in the Southern Hemisphere, as there are lots of really good southern-only constellations visible, such as the Southern Cross, of course, which is standing upright for once. High in the south in the middle part of the evening. I say for once because for a lot of the year it's sort of lying on its left-hand side or right-hand side during the sort of evening hours when most people will be out having a look for it. But at the moment, yeah, it's upright and nice and high if you look down south. Of course, using the Southern Cross is one of the ways that you can find south. There's a little trick you can do to use the Southern Cross to find the south celestial pole, and then you just drop from there down to the southern horizon, and that tells you exactly where south is. So when I say that the Southern Cross is in the south, you have to know where the south is, of course. But I think most
It's pretty easy to tell the Southern Cross, I think. It's one of the best-known constellations, that and Orion, I'd say.
Yeah, it's probably one of the most famous constellations, that's for sure. And once you spot it, once you learn how to see it, then you never lose sight of it. You can always spot it if it's above.
That's the way I navigate across the skies.
However, you know, I mean, I've spoken to lots of people who come from America or England or wherever, and they've come down to Australia, and they want to see the Southern Cross. And they find it very hard to find because they expect it to be really big.
Yeah, they keep looking at the False Cross, don't they, and think, oh, that must be it.
Yeah, the False Cross is nearby. It's a larger version of the Southern Cross. The the Southern Cross in area is actually the smallest constellation in the sky. It's actually really small. The stars are quite bright and it's prominent, but yeah, if you haven't had it pointed out to you, you could miss it because you're looking for something much bigger and grander, I suppose. But it's a great constellation. It really is a tremendous little sight down there in the Southern Hemisphere.
Sad that we're losing the stars, just so much light pollution around that. Well, for a start, one of the stars has almost gone completely from average viewing in the city.
In the city, yeah. Well, of course, as we know, cities are very heavily light polluted. That's all the street lights and things reflecting light up into the sky rather than down on the ground where the light should be going. And this light is actually making the sky glow. Our actual atmosphere is glowing faintly. So what should be nice pitch black is actually sort of a dull grey or worse.
What is that? Is that the light reflecting off molecules in the atmosphere or what?
Well, you do get that. So cities, for instance, have a lot of smog. So you get light reflecting off smog, and so you go outside and the city night sky appears grey or orange or
fine
whatever,
particulate matter.
Colour street lights are around. But no, the actual molecules in the air do glow a little bit and they release a bit of light. I mean, they always do. The light pollution makes the sky glow a little bit, makes the air actually glow. It's very faint, but it's enough to drown out the faint stars. So if you live in a light polluted area in a big city, you're not going to see too many stars. You should be able to see 2,500 stars roughly with the naked eye if you're in a really dark spot. That's how many stars you can see, 360 degrees around the horizon and 180 degrees from horizon to horizon. But in the city, sometimes you can only see dozens or 100 at the most or whatever. And as you say, the faintest star in the Southern Cross is of a brightness that, if you're in a light polluted sky, then it's going to be fainter than the glow of the sky. So that's the way it's heading. Tell you what, though, two stars that will take a long time to fade from view with light pollution are the ones they call the two pointers. They're just to the left of the Southern Cross if you're looking south, and they're in the constellation Centaurus, and they're called the pointers because they seem to point towards the Southern Cross. To the right of the cross are the constellations Carina, Vela and Puppis, which are famous constellations down here in the south, and they're full of fantastic star fields and nebulae. You can just make out a few of these beautiful star clusters and nebulae with binoculars, but you'll need a telescope, but even a small one will do, and you'll get a much, much better view if you can sweep it through the star fields of the Milky Way there. Further over to the west, just after the sun has set at this time of year, you can see the constellation Orion, the Hunter, sort of setting down there on the western horizon. Nearby is Sirius. Now, Sirius is the brightest star in the night sky. It's also the brightest star in the constellation Canis Major, or the Greater Dog. And just a little bit to the north, you can see another fairly bright star. This is Procyon, or Procyon, which is actually the brightest star in Canis Minor, the Lesser Dog. There are a couple of these sort of constellations up there that have a big one and a small one. The northern half of the sky at this time of the year, for us in the south at least, seems fairly devoid of bright star fields. But there are some famous constellations up there. You've got Leo, there's Cancer and Virgo, all visible during the evening hours in May. Virgo is a favourite of amateur astronomers because with a telescope you can see hundreds and hundreds of distant galaxies. It's the constellation that's known for galaxies.
Is this because of the Virgo cluster?
Yeah, they're part of the Virgo
super cluster, really, isn't it?
The Virgo cluster is part of the Virgo supercluster and just gets bigger and bigger. But yeah, millions of light years away, there's this enormous grouping of galaxies. Things tend to want to clump together in the universe, either on smaller scales or larger scales, and on this very large scale out there, millions of light years away, there's this enormous cluster of galaxies called the Virgo cluster. A lot of these galaxies, if you look at them through a telescope, they just look like tiny smudges, and sometimes you have to use what's called averted vision. This is quite common in astronomy when looking through a little telescope or even a large telescope. Averted vision is where you don't look at it straight on. You sort of look at things out at the corner of your eye, and that's because the central part of your eye is really good at picking up bright things, and that's really good during the day, but the rest of your retina is really good at picking up faint things. So a lot of these things you look at out in space through a telescope are faint, so if you use averted vision, just sort of look at the outside of your eye, then you can make them stand out a lot better. So that's up in the north. In the east in the sky at mid-evening through May, the constellation Scorpius is just beginning to poke itself above the horizon, and as the night progresses, the full constellation will become visible, followed a little later actually by Sagittarius. They're right next to each other. And when we look at Sagittarius, we're actually looking in the direction of the center of our galaxy. So plenty of things to see in both Scorpius and Sagittarius, nebulae and star clusters and things. It really is great if you can get a telescope onto it. If you don't have one of your own, see if you've got a friend or someone who's got one, or there are lots of observatories around Australia run by astronomy clubs or others. See if you can get a view through a telescope in Sagittarius. It really looks amazing. Now, as far as the planets are concerned, Jupiter is the star of the show this month, no pun intended. That's because it reaches opposition on the 9th. Now, we've spoken about opposition before on the program. Opposition is the word we use to say that on that day, the planet is exactly opposite in the sky from the sun as seen from Earth. The practical upshot of that is that as the sun's going down in the west, the planet is rising in the east. And that means you can see the planet all night long. which is what astronomers really like, because if you're working in the evening when you get home, you can have a look at it later in the night, or vice versa, or if it's cloudy in the early part of the evening or it's cloudy in the morning, you've got 12 hours to look at this planet. And of course, a few hours after it's risen over the eastern horizon, it's up nice and high. And the higher things are in the sky, the better they are to see, because you're looking through less and less atmosphere to see them, so you're getting less of a blurring effect. So yeah, Jupiter will be rising in the east. You'll see it all night long. The same pretty much goes for the rest of the month. Jupiter will be rising a little earlier each day, and you really can't miss it. It's in the eastern part of the sky, and it's big and bright. It looks like a big, bright star, but it's actually the planet Jupiter. Venus is another planet that looks bright all the time. It's visible low down in the west after sunset, skirting along the horizon. And as the month goes on, it will be moving sort of slightly northwards as each day of the month progresses. So if you want to have a look at Venus, make sure you've got a fairly clear western horizon, no trees and buildings and things in the way, and you should be able to see it after the sun has gone down. What are the other planets? Saturn and Mars, they're visible later in the night this month, with Saturn rising in the east around about 10 p.m. at the beginning of the month, with Mars following about an hour later. You can use the moon to help you identify these planets, because, you look up in the sky and you think, what's a planet, what's a star? Well, the moon sort of goes past the planets as seen from Earth each month as the moon goes around us. So this month, the moon will be very close to Saturn on May the 4th.
May the 4th be with you.
Star Wars Day, isn't it? Yeah, May the 4th. The moon will be right next to Saturn. And a couple of days later, on the 6th, the moon will be next to Mars. So that's a handy way to identify the planet. And finally, if you want to see the innermost planet, Mercury, you're going to have to get up before dawn. At the start of the month, it'll be rising at about 4:30 a.m., which is about 2 hours before sunrise. So you'll be able to see it out there in the east, above the eastern horizon. It looks like a small but intense and bright star, but it's actually the planet Mercury. But as the month progresses, Mercury's going to be dropping lower and lower in the sky as each day goes by, and so towards the end of the month, it'll become lost in the glare of the sun. So if you want to try and spot it, first couple of weeks will be the best shot, but as I say, you've got to be up nice and early before the dawn.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.